Hey everyone, in this video we are going to look at some questions about tests and intervals. So we're just going to walk through some sample problems together. Alright, first question. Production managers on an assembly line monitor the output to be sure that the level of defective products remains small. They periodically inspect a random sample of items produced. If they find a significant increase in the proportion of items that must be rejected, they will halt production until the problem is identified and repaired. Okay, in this context, what is a type 1 error? Now, let's think about this. If you remember from the video where we talked about errors, we need to be able to distinguish between the two types. So a type 1 is where the null hypothesis is true, but we mistakenly reject it. So if you think about this case, a type 1 error, if the null hypothesis was true, that means the product was good, but we claimed that it was bad, but we rejected it. Sorry about that. Let's just try that again. So that means this guy on the assembly line, he got a product off here and it was actually a good product, but he rejected it. So in this problem, if we look back at what the question says they want to make sure that defective products remain small. So in this case, we could actually say the defective product level was small, but they halted production anyway. So the products that were coming off of the line were actually good, but they rejected the products, meaning they halted the They halted the production anyway. So a type 1 error in this case, defective level was low, but production was halted anyway. So that would be our type 1 error. Now, the second question asked, what is a type 2 error in this context? So if we think about that, a type 2 error is where the null hypothesis was false, but we did not reject it. So in this case, that means your product is bad, but you did not reject. So, to be a little bit more specific, because we're talking about the level of defective product. So in this case, level of, let me try again there. Level of defective product was high, but they did not halt production. Okay, now let's go back and look at the questions again. Question 3 for this. What type of error would the factory owner consider more serious? So if we look at our two types of errors, type 1, the product was good, but they rejected it. Now, in a type 1, the defective level was actually low, meaning they were making good products, but they stopped the production anyway. And then if we look at that compared to a type 2, the levels of defective product was high, but they did not halt production. So we're wanting to know which one the factory owner would think is worse. Well, in this case, I think that it would have to be a type 2. I guess it really depends on the type of product too. because the repercussions for a type 1, they stopped production, which means they're no longer making products, therefore they have less to sell, even though they were making good products. Whereas if you think about type 2, they are sending out bad products to their customers. And I really think that would be the worst, because they're sending out products that are no good. That means they're going to get complaints from customers, and overall that'll probably decrease sales in the long run. They might have to do a recall, something like that. Okay, then the fourth question for this: what type of error might customers consider to be more serious? I think in this case, definitely a type 2. No customer wants to buy a defective product. They would rather the company lose out a little bit of money to stop production and get things right, rather than them paying money for a bad product. So I think definitely type 2. Okay, so question 2. A company is sued for job discrimination because only 19% of newly hired candidates were minorities, when 27% of all applicants were minorities. This is strong evidence that the company's hiring practices are discriminatory. So basically what we have here, a company, it did its hiring. Company, I'm sure, does not think it's discriminating. Someone has the idea that, you know, I'm not so sure I agree. I think I want to test that. So when we look at this, basically, that's kind of the mindset that we have to keep here. So first of all, whoops. Let's see. First of all, is this a one-tailed or a two-tailed test, and why? Well, I think it's pretty easy to see on this one that it's a one-tailed test, because only one type of error here is, or only one type of, we want to look basically, are they hiring the correct amount of minorities given the percentage of applicants? They wouldn't be getting sued if they were hiring more minorities than the percentage that applied. They're only being sued because they hired less. So I think this one is clearly a one-tailed test, because like I said, they wouldn't be getting sued if too many minorities were hired. Now the second part, in this context, what would be a type 1 error? So think about this. The company is claiming that it is not being discriminatory. So if we think about this in terms of a null hypothesis, the company believes it's not discriminatory. Someone is arguing with this, and they want to determine if the company is being discriminatory or not. Now, when you think about a type 1 error, that's where the null hypothesis is true, but we mistakenly reject it. So in this case, a type 1 error would be the company actually is not discriminatory, but we reject that and say they are. So saying the company is discriminatory when they are not would be a type 1 error. Now, a type 2 error in this case, type 2 is based on, again, using the null hypothesis, it's based on the fact that the null hypothesis actually is false, but we failed to reject it. So if the null hypothesis was false, that means the company actually was discriminatory, but we decided that they were not, okay? So deciding the company is not discriminating, oops, when it is. Okay, so those are our type 1 and type 2 errors. Now, let's see. The fourth part, in this context, what is meant by the power of the test? Okay, power is the probability of detecting type 2 error, okay? Power is associated with our type 2 error. So in the context of this problem, our power of the test is going to be the probability of detecting if the company is actually discriminating. So that's going to be our power, detecting if the company is actually discriminating. All right, the next part, if the hypothesis is tested at 5% level of significance instead of 1%, how will this affect the power of the test? So if the hypothesis is tested at 5% instead of 1%, how will this affect the power? Now, in this case, we're talking about level of significance, so we're talking about alpha. So if alpha, it's a terrible alpha. If alpha increases, alpha is the probability of a type 1 error. So what that does is that increases our power, okay? That increases our power. All right, and then the last part for this one, the lawsuit is based on the hiring of 37 employees. Is the power of the test higher than, lower than, or the same as it would be if it were based on 87 hires? So when we look at this, we're now seeing N is increasing. Our number of, our sample size is increasing. So as sample size increases, we're going to see this being lower now, okay? So is the power higher than, lower than, or the same as it would be if, and I wrote that wrong, as N increases, the power gets higher. So for this question, since our N is smaller, we would say that the power in this case is lower. So when N equals 37, power is lower since N is smaller. Okay, so as number of as sample size increases, the power will also increase. Okay, next question. A company is willing to renew its advertising contract with a local radio station only if the station can prove that more than 20% of the residents of the city have heard the ad and recognize the company's product. The radio station conducts a random phone survey of 400 people. So the advertising company will only renew its contract if the radio station can show that more than 20% have heard the ad. So for this one, whoops, I haven't read the question yet. First, what are the hypotheses? Okay, what are the hypotheses? So on this one, our null hypothesis, we are assuming the probability that hears the ads is 20%. So H sub O, P is equal to 0.20. Now, the company wants to show that more than 20%. So their alternate hypothesis, they want to show that the probability is greater than 20%. So those are going to be our two hypotheses. The station plans to conduct this test using a 10% level of significance, but the company wants the significance level lowered to 5. Why is that? Now, if you think about in terms of what the level of significance gives us, a lower alpha is actually going to give us more proof that we're making the right decision. Because if alpha is too high, then your probability of a type 1 error is also too high. And remember, a type 1 error is the null hypothesis is true, but we reject it. So by setting alpha too high, we are basically kind of discrediting some of the proof that we're making the right decision. The third part, what is meant by the power of this test? So in this case, the power is going to be the probability of deciding that P is greater than 0.20 and that actually being true. Okay, so the power is the probability of deciding that actually 20%, more than 20% hear the ads, and then that being true. Okay, next part. For which level of significance will the power of the test be higher? For which level of significance will the power of the test be higher? So on this one, the 10% significance level would actually give you a higher power. And the reason for that is we have more chance to reject H sub O. Okay, we have more chance of rejecting the null if that's true, or if we use 10%. They finally agree to use 5% significance level. So the company said they wanted them to lower it to 5. The radio station finally agrees. But the company proposes that the station calls 600 people instead. Will that make the risk of type 2 error higher or lower? So on this one, we kind of mentioned this in the last question. This would actually make that lower, as N increases, the power increases, and therefore the probability of a type 2 error decreases. Okay, so as N increases, the power increases, and the probability of a type 2 error also will decrease. All right, then the last question. During an angiogram, heart problems can be examined via a small tube, which is called a catheter, threaded into the heart from a vein in the patient's leg. It's important that the company that manufactures the catheter maintain a diameter of 2.00 millimeters. Each day, quality control personnel make several measurements to test this. And I'm going to give you the hypotheses and the alpha level, and then we're going to answer some questions about these. So first of all, we have to go along with this. H sub O is mu equals 2.00. H sub A, mu is not equal to 2.00. So the company maintains that it keeps a diameter of 2. Someone wants to test that this is true. So they're claiming that for the alternate that it is not. And we're testing this at an alpha level. I don't know why it does that sometimes. Of 0.05. Okay? So this is our information that we have to go on here. Now, first of all, is this a one-tailed or two-tailed test? And in the context of this problem, why is this important? Well, one thing to note is the fact that we're just testing that the average is not 2. We're not saying, we're not saying that it's higher, we're not saying that it's lower, we're just saying that it's not. Okay, so that indicates that this is a two-tailed test because we're saying that errors can be made both ways, where it's either greater than 2 or less than 2. In this case, when you're talking about a piece of medical equipment, I think it's really important because think about if you had a little tube going in your vein from your leg to your heart, would it make a difference if the tube was the wrong size? Absolutely. If it's too big, that can cause problems. If it's too small, It just won't work right. They won't be able to read things the way they should be. So both ways, big time problems when you're talking about medical equipment. Now, the second part, explain in this context what happens if the quality control people commit a type 1 error. Okay, so let's look at what our H sub O is. Type 1 is the null hypothesis is true, but we mistakenly reject it. So in this case, a type 1 error is going to be the catheters were fine, but I don't know why it does this. Sorry. Okay, so for the type 1, the catheters were okay, but production was stopped. Okay, so that would be our type 1 error. Now let's look at the last question. Explain in this context what happens if quality control commits a type 2 error. So on this one, for type 2, remember type 2 is the null hypothesis is false, but we fail to reject it. So in this case, catheters were not 2 millimeters, but production continued. Now, I didn't ask in this one, but I think it's important to think what type of error would be worse in this case. I think when you're considering it's medical equipment, I think it's worse by far to have a type 2 error. That means they're shipping out and using catheters that are not 2 millimeters. They're either larger or smaller, which essentially could cause someone great harm or even death. So a type 2 error would by far be the worst in this case. Okay, so those are just some questions about hypothesis testing, error, and power. And that is all for this video.